Good morning all. This is Saranya from Department of Computer Science and Engineering, St. Joseph College of Engineering, OMR. Today I am going to take about machine learning. Directly I am not going into the topic. Before going into the topic, we'll see something briefly about machine learning. What is machine learning? Machine learning is something where we want machine to think, act as if what a human is doing. As a human, what we will do is we'll think something, we'll process something, we'll react something. As a newborn baby, for example, I'm saying if a baby is born, we are feeding some sort of data like how to eat or how to sleep or how to crawl. These are the things that we are how to walk. These are the things that are data which we are feeding manually. Once the baby has been grown up, the baby started to walk himself. So what happens here is, once the data is fit as a walk or crawl, whatever it is, once the baby is been went into the adulthood or grown up stage, they will automatically do their work without any sort of interventions. So the same sort of thing is being we are trying with the machine. Like, we will be giving some sort of data in a previous time in a before way, where that machine is going to process the data and it has to think how the humans is going to think, the same way that machine is going to act. So this is what the overall concept or overall gist of what is machine learning. We'll see, like, ability to learn. This is the major gist of machine learning. How the machine is going to think on itself and how it is going to process. This is what the ability to learn. This will be done by the machines, which is not the direct machine, which can be incorporated in the software, where it will be incorporated in the hardware. Where, as a real-time example, we can see as all the AI models. What could be the AI model here? All our day-to-day life inventing things, which is nothing but ChatGPT, Gemini. These things are a AI model, which we will be calling it as an LLM model. Before going to these things and all, we'll see what are the types here. And in machine learning, we have majorly of 4 types. One is supervised algorithm or supervised learning. Second one is unsupervised. Third one is semi-supervised or self-supervised. And fourth one is reinforcement. We'll see what is what and what sort of example which has been applied to a day-to-day basis. What is supervised learning? Supervised learning are the labeled data set which is being given to the machine to process and to give a predicted form of output. See, what is labeled data set here talks about is, we know these are few sort of data which is going to interpret, and we will be having some sort of own kind of assumption or a prediction that this will give only this sort of output, which is a kind of a prediction, or we will have some sort of expectation over it, like this is what the overall output will be. Even though we are not aware that this is the exact output, we will be knowing something like this is how the pattern will be. So this labeled data set will be given to the machine to process itself and to predict the output or predict the target value, which we will be seeing at the when algorithm is being learned. Here we can say example. What sort of example we can say is spam, email spam. See, here we can connect to the real-time example that in our email we are getting a number of mails. There are some mails which has been automatically sent to the spam, and some mails which has been reflected in our inbox stages. In what way it will be directly sent to the spam is based on its advertisements, based on its some ad and some sort of keywords that referring it's kind of the like with the referring keyword, it will be denoted as either ones or zeros. If it is zero, it will be sent to the spam. If it is one, it will be reflecting to the inbox stages. So this is what the overall idea of a supervised learning. In this supervised learning, we have set of algorithms. I'll write algorithm over here. The set of algorithms that we can able to see based on two things. Here the two things are classification and regression. What is classification? Classification is nothing but where the data will be in a discrete format. And here in the regression, the data will be in a continuous format. In this regression, we have a logistic regression and linear regression. So these are the types of supervised learning. When coming to the unsupervised learning, it is just the vice versa of this one, where here we will be having a labeled data set. But whereas in the unsupervised, we will be having a unlabeled data set. Since it is an unlabeled data set, we can't able to predict the output, like what sort of output it will be there. So in that case, what we will do is, this labeled data set will be interacted with the machine. If the output is not as per the machine's language or as per the machine expectation, it go itself into the machine by adding some weights or adding some layers or some sort of calculations. It will be manipulating itself and it will be giving the output. Here we can say example as a e-commerce. How the e-commerce will work? See, basically as a customer, let's take an example. Being a customer, I'm the one who has been already searched with some sort of product. For example, it can be a cosmetic products. Since I have been searched about the cosmetic products, after a 1 week of purchasing or whatever it is, again after the 1 week, if I start to purchase something, if I am going with electronic gadget, it will automatically show only the cosmetic products. How it has been showing here is, there is some sort of data which I have been given to the machine or given to that e-commerce website or whatever it is. So based on previous data which has been unsorted way, that will be predicting it's what sort of data I will be referring to in the future. Here we can say as a recommendation system where the same sort of things will be applying our YouTube search, Amazon search, and all other social media. Even our Netflix will also work in the same or moderate wise of unsupervised learning. And here there are few algorithms which will be seeing here is, I'll write this way: clustering, association, and then dimension reduction. This clustering and dimension reduction will plays a major role in our day-to-day performance and day-to-day activities, where it has been incorporated directly or indirectly to our daily basis activities. And then comes your semi-supervised or self-supervised learning. Here, what is self-supervised learning? See, it is some more or similar sort of unsupervised learning where the unlabeled data set will be taken, which is being converted into a labeled data set, and the output will be or the prediction will be happening over here. Here we can consider example as a Google Photos. How the Google Photos will work? We have a n number of photos. That n number of photos will be matching with the already taken unsimilar data or unsimilar pattern features, whatever it is. Based on the feature which has been already taken, it matches as the same sort of set of 10 or 12 photos, and it shows the as a notification where we will be seeing the upcoming photos and all. So this is what the example of self-supervised learning. And coming to the reinforcement learning. This reinforcement learning is nothing but the trial and error method, which is the common thing which we are seeing in our day-to-day life, where we can take an example of autocorrection, where if we type, if we start to type one word, it will be reflecting the some other word. But where we will be recorrecting it and saying it as a this is what we wanted, that we can say. And apart from that, main example where we can say is chessboard, all other things, or game sorts of a things, all other things. Because whenever the one move is made, if at all it is a wrong move, we can go back, correct it, and we can make a correct move out of it. The main thing here we are following is this trial and error method, where it has a free model based learning, where it shows about the service and mainly of your policies. With policy, it has a reward action. So these are the keywords that we will be focusing when you are seeing with the reinforcement technique. We have seen some basic concepts of machine learning. Now we'll see some of the basic algorithms which has been dealing in the machine learning. Now we are going to see about the SVM. SVM is nothing but the support vector machine. This comes under the supervised learning. And here, as we already discussed, in supervised learning, we have a two sort of thing, which is a classification and regression one. And this SVM can be dealt with both the things, which is a classification and regression. But mostly in real-time application, it is been dealing with the classification. Now, what is SVM? Like I'm saying about the idea of the main SVM. This support vector machine, how come it will work? For that, we are going to see now. This support vector machine will say is about how the classification between the two sort of data is being taking place. Consider the example. We'll consider the example in a graph way. Consider here there are two sets of data points or a data set, two types of data sets. One is being represented as a star, another being represented as a small circle basis, where which here we will be considering it as this is one data set and this is one data set. And here this SVM, what it will do is it forms a straight line, which means it separates the two set of data sets. On the whole, this data set will be on the whole present in the space, where in space there will be a basis vector and span. This basis vector, where all the data points is a condition where all the data points will be independently present without depending on each other directly. This span is a space which is being carried out on the whole. And here, when coming to the machine learning concept, all the algorithms will be imagined in a way how it is being placed in a two-dimensional and the three-dimensional way. And here, we have been representing the two sorts of data points. One data point is in a star form and the second data point in the circle form. Here, placing these two data points in a empty space or in a plain space, we can imagine that it is being represented in the 2D form. Since it is a 2D form, only one line or only one thing is enough to separate these two things. If at all, just imagine if it is being placed in a 2D surface, there is a two set of data points. If I wanted to segregate these two data points, the one line has been enough to segregate this. So this, if I draw a line like this two sets of data points will be segregated. The same way, it can be separated by this way or this way or this way. Whatever it can be segregated based on how the data set has been scattered all over the spaces. And here, this is the scenario for the 2D set. If the data is being scattered in the space, not as a 2D but as a 3D, this one line of segregation will not be enough to segregate the data sets. How come this 3D will be working? when it is being segregated all over, like here, where if at all it is a 3D, imagine this is x-axis, y-axis and z-axis. Since it is a two-dimensional, it is being segregated as a with a straight line. If it is a 3D, how come the segregation will happen? The segregation will happen only once it is being tilted and it will be viewed. And before going into this 3D concept, we'll see one more thing. As I said earlier, this one line is enough to segregate the two set of data point. This one line is called as a hyperplane. And here in 2D, I'm saying especially, this hyperplane is not mandatory to be only one hyperplane. There can be a multiple hyperplane in a 2D space of SVM. Here, in 2D space of SVM, I have segregated this one line and taken this line as a thing which I am going to discuss now. Even I can segregate it with a, one second. Not only as this way, even I can segregate with this way or even this way. There can be n number of things. And here, when segregating, there can be, as I said earlier, there can be a n number of lines to separate two sets of data points. And when separating this two set of data points, imagine I am drawing a 3 line here. And this is the distance between the major line of segregation, which has been the maximum margin. This distance has been between the major hyperplane is being said as a maximum margin. And this is how our 2D plane or two-dimensional features will be segregated. And when coming to here, the 3D plane, just imagine there in 2D plane we have a x and y axis. We know like how the 2D plane will work. Consider this is the room, this is the y axis and this is the x axis. If it is a three-dimensional room or three-dimensional view, how we will be considering it is, we'll consider this way also, as if we are thinking of the cuboid or some other thing. So same way, just think, if it has been scattered, all the objects has been scattered in this room in a three-dimensional way, where we are going to segregate one object as a one thing and another object as a one thing, we can't directly do here. What we do here is, we'll just imaginarily, what we'll do is, we'll tilt the imagination. We won't see in this way, we can able to see in this way, we can able to see in this way, or even this way. It's all about our imaginary. Here what the major part of the algorithm works here. So when this dimension is being changed to something like this, what happens here is, the data points will be divided into two things. Just in an imaginary way we are saying here. From 3D it is being tilted and it is being viewed in this way. Here we can see the stars are being here and even the zeros are also here. And by drawing a hyperplane, by just neglecting this one, we can draw a hyperplane in this way. If at all we tilt in this way, even this 0 will come here and this stars will be represented here and 0 will be represented here. So this way even that 3D can also be tilted, viewed, and it can be also segregated using this one special line called hyperplane. And here there is not only the one sort of supervised learning, there is in the supervised learning, one sort of SVM, there is some more thing called linear SVM and non-linear SVM. I'll write here linear SVM, non-linear SVM. This linear SVM is nothing but where we can able to segregate the two data sets individually just by drawing a straight line is called the linear SVM. If at all the two data set cannot be segregated into two different parts just by drawing the line, if it is drawing the line is not possible, then it comes under your non-linear SVM. This will be classified as a linear SVM classifier and non-linear SVM classifier. And here, how come the representation will be here? And how the formula will be represented here? And here, see, consider this is an x-axis and this is the y-axis. And here, as we discussed earlier in this SVM, we have been segregating the two data sets as a zeros and stars with a one margin line. As I discussed earlier, there can be n number of margin line. Considering this as the center, like in our imaginary part, if we consider this as a 0, this becomes +1 and this becomes -1. So with this consideration, we will be writing it as a 2 power determinant of W. Max is equal to 2 power determinant of W. This is how the SVM segregation will be happening here. And this is how the space distribution of the data set will be happening in the SVM algorithm.